Yeah, good day, viewers all over the world. I remain Salumaj. In today's class, I'll be talking about inorganic chemistry. I remember when I did our introduction to chemistry, I spoke about physical chemistry, that is called calculation chemistry, then organic chemistry, inorganic chemistry. So at least I've dealt a bit with organic chemistry. I talk about hydrocarbons generally. Today, we are talking about inorganic chemistry. Inorganic, inorganic chemistry. Inorganic chemistry today, I'll be talking about elements, compound, and mixture. Elements, compound, and mixture. I've told us the meaning of chemistry. Chemistry is what you deal with every day of your life. I remember when I was doing introduction to a chemistry class, I used this marker as an example that a chemist is concerned with the chemicals that made up this thing you can see. Yeah, today I want to talk about element, compound, and mixture. If you are going for geology, if you are going for engineering courses, any of the engineering courses, if you are going for pharmacy, medicine, applied physics, please don't miss my science classes. Don't miss my physics. Don't miss my chemistry. And please don't miss my mathematics for any other thing, please. So today, what is an element? What is an element? They will tell you an element is a substance that cannot be split. I repeat, you cannot break it down into smaller substances. You cannot break it down. And we have over 103 elements around, scattered everywhere. You find them in the water, you find them in the air. Oh, let me use this opportunity to even tell us that oxygen is highest in the sea. While in the air, we have nitrogen to be the highest in terms of percentage composition. So today I say I want to talk about elements. And I told you that these elements, they are spread around. So scientists now came together and arrange these elements into groups. They arrange them into groups called periodic table. I'll still teach us periodic table as a topic. Please don't miss that class because I'll be talking about ionization energy and some other properties there. So we have all these things arranged into group, into what they call it. We have group and we have the vertical and the horizontal arrangement, the period and the group. Don't miss it, please. So our elements, you can talk about carbon. Carbon is an element because it cannot be broken down into another smaller substance or substances. So in what they call it, our elements now, you can talk about oxygen, you talk about nitrogen. You can see I'm mentioning it one by one. Nitrogen, oxygen, silicon, aluminium, and so on and so forth. Now, when you are now talking about compound, a compound is a substance or a compound is formed when you have elements combined together chemically. There will be a chemical change. That is the word. There must be what? A chemical change. By the time calcium reacts, calcium reacts with carbon, reacts with oxygen. Let me just put it that way. It can give you calcium carbonate. That's your marble. If you now look at it, this calcium on its own, this one is a white substance. This one is carbon, black substance, this is oxygen. By the time you react them under a particular temperature or what they call it, or other chemicals, they will generate what? Marble. This one now has a different what do you call it, property compared to this. These are elements, these are other elements, these are other elements. They have come together to form a new substance. This substance is now called a compound. It's a compound because there is what? A chemical change. Once there is a chemical change, there is what? A compound being formed. At this point, let me even use this one to explain. Please don't mix my physics class. If you look at water, 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 that's the H2O. Water in liquid state. Let's say this liquid state. Liquid state. You can have water in solid state. That's your ice. You can have water in a gaseous state. That's vapor. What has happened to these three? When you have your ice, by the time you apply it, let's say this is your Bunsen burner. Let me just use this as Bunsen burner. By the time you apply it to this ice, this heat will melt to give you water at liquid state. The heat that you have applied to cause this thing, to cause this ice to melt into liquid, is what we call the specific latent heat of what? Fusion. We are going to do that in our specific capacity when I'm teaching you that in physics. I will explain, I'm going to piece that for you. But just notice that the heat required, because you must heat water or any substance to a specific heat capacity for it to change into another state. Now you have heated this solid, which is ice, to form liquid. If you continue with heat, further heat, heat, you have heated this one to generate heat. Further heat, by the time you heat this liquid further, it will now generate what? Vapor. That is when you are boiling water. After a while, what do you see coming? You see vapor. If you continue with that heat, the whole thing will what? Evaporate. You will not see the water again. It will change from liquid to gas. That is what? Change of state. It has changed from solid, which is ice, to liquid, then from liquid to gas. And if you now look at it, let's say I've used something, I've connected this one to a condenser. A condenser can condense this vapor back to liquid. A condenser, that's another apparatus that will trap this gas. Although this one will not be a cold water that will be running around this pipe. As it's running around this pipe is hollow. But around the surface of this gas, you have cold water that will be taking the heat away from this vapor. Then it will be turning it back into liquid. That is heat change. You are changing it from, you are taking the heat. By then, let me go into physics. Then I'll be talking about MC theta. MC, so don't let me talk about that yet. So by the time we get to specific capacity in physics, I will explain further on that. I just wanted to also see something here. If you now look at it, water has changed from ice to gas. You can condense it back to ice. What has happened there is that water has not changed its chemical structure or chemical property. Though you have applied heat to it, it has changed to another state, but it still retains back its initial state. That is called what? That is not what? A chemical change. You can call that to be what? A physical change. It has changed from ice to liquid. Your eyes can see that's physical change. Then from liquid to what? To gas. That's physical change. Fine. Let's now go to mixture. In our mixture is the what? Combination of two or more elements without a chemical change. This is what? There will be a physical change, but not a chemical change. For instance, If I mix sand and water together, or this is sand and iron fillings, you mix it together. By the time you mix the two together, by the time I bring magnets, what happened? I can use magnets to bring out the iron fillings in the sand. Another thing, maybe you have mixed water and oil together. You can separate this. That is what? Just a physical change, not a chemical change. The chemical change, the whole thing will change. The whole thing will change. It's just like the way we make soap, saponification reaction. You know, soap, by the time you bring your caustic soda, your soda ash, your soda ash, your caustic soda, which other thing again? That we add to this. You can add perfume to it. You have sulfonic acid, fine, sulfonic acid. So another compound. By the time you add all these together, it will form soap. That soap is what you use in washing. It has formed another compound. It cannot go back. It cannot be separated into this again. It has undergone what? A chemical reaction. Therefore, I can't get this one back. This has combined together to produce soap. I believe that is clear enough. That's just the difference between elements, compounds, and mixture. Mixture can be separated. Compound cannot be separated. It's just like other like mixture now. They're not talking about separation techniques. Whether you can use chromatography, you can use sorry. Let me just run through separation techniques. Where you can use chromatography. Chromatography. You can talk about fractional distillation. Fractional distillation. You can separate based on their sizes, in based on insolubility, or you can each one to bring out one, the other one is separation techniques. Like chromatography now, they use it to bring out chlorophyll. The basic technique of chromatography is talking about the rates at which a chemical that has very close what they call it, or they can even not be close, maybe different boiling points. By the time you put them in, you can either use paper chromatography or column chromatography. By the time you put it, what happens is that they will now be running out of the system. Be running out of the system. Then you can now separate them, separate them, separate them. You can have three colors mixed together. You can have three colors, four, five colors mixed together. Physically, you may not see, but it can be separated using chromatography technique. By the time you get to higher station, you will see what they call it, this chromatography machine, how it's being done. For fractional distillation, majorly they use this one in what they call it, refinery. That is what they use in separating crude oil. Now I've told us about crude oil. If you are still strange with crude oil, please go and watch my introduction to chemistry. I did justice to crude oil. So they use fractional distillation because those things they have very close boiling point. So they can use fractional distillation. As one is coming out, there is water that will cool it down. Like just like that in different columns. You can get it that way. I believe that is clear. So in our next class, I'll talk about valence and valency electron, the periodic table. Please don't miss my class. Don't miss my chemistry class. Don't miss my physics class. If you have not subscribed, please do so now because we have lots of interesting topics coming in now. A lot of interesting topics. Thank you very much for those appreciating me. God bless you.